This video is about real numbers and the various types of numbers that make up that large set of real numbers. So let's start talking about just what the real numbers are. They're the set of numbers which correspond to the points on the number line. So for example, that might be the number 1, or this might be the square root of 2, or maybe we have pi, or perhaps this is negative 2.3. These are all real numbers. There's subsets of the real numbers, and that's what we're going to talk about first. The natural numbers are known as the counting numbers. Now these are the numbers a young child would first use. They're not going to start by saying something like 7/8 or negative radical 3. These are not counting numbers. Rather, these are the numbers such as 1, 2, 3, 4. Those are the natural numbers. Now the whole numbers are the natural numbers plus one more, and sometimes you might be able to remember this by thinking of this as the whole, and that's the number that we add in to get the whole numbers. Now some math texts may use the term natural numbers for the whole numbers. There's some confusion in the terms sometimes, but the terms I'm giving you in this video are pretty widely used. Integers are all the whole numbers which you see below and their opposites. That entire set gives us the integers. So you notice that the whole numbers are integers as well as their opposites. This set continues both to get larger and larger as well as to get smaller and smaller. It continues in both directions. Now what are there besides the integers? Aren't there some in-between numbers such as maybe 1.5 or perhaps 4.1 or maybe, let's say, negative 2 and 1/10? Those numbers which I've just written are not integers, but they certainly correspond to points on the number line. So if they correspond to points on the number line, they are real numbers. So that brings us to another type of number, namely the rational numbers. The rational numbers are all the fractions. To be a little more precise, they're the numbers which can be written as a over b. This is, we're really going to define a fraction here. It's a divided by b, where both a and b are integers. And we have to make sure the denominator is not 0. So this is the form that gives us fractions or gives us rational numbers. There's a few of them on the number line. I certainly didn't write down all of them, but that's some of the rational numbers. Now we want to make a couple comments here. The integers themselves, here's my integers, these are also rational numbers. For example, 6 could be 6 over 1, negative 5 over 1. These integers are all rational numbers. Even 0 could be written as 0 over 1. That's equal to 0. So all of these integers are rational numbers, as well as all those in-between fractions. Now as decimals, rational numbers are repeating or terminating. For example, here's some decimals which either terminate or repeat, and these are all rational numbers. And if you have a rational number, it will be either a repeating or terminating decimal. What else? Are there any numbers other than rational numbers? It seems like if you take a point on the number line, that should be some kind of a fraction, you know, like maybe that's 1 4/10, maybe that's 3 2/17. It seems that any point on the number line would correspond to some fraction. However, that's not true. It may not be intuitive, but there are real numbers that are not rational numbers. That means there's points on this number line which do not correspond to any fraction, no matter whether you subdivide it into fourths or 20ths or 19ths or 230ths. These points miss all those fractions. They are not fractions. Now here's some example of real numbers that are not rational. Square root of 2, square root of 3, pi. these numbers cannot be written as fractions, so they are not rational. And we call these the irrational numbers. So irrational numbers are the real numbers that cannot be written as fractions, or in other words, are not rational numbers. Now as decimals, they're non-repeating and non-terminating. That means they continue on, and they don't end. They never end, and they don't have a block of repeating digits at the end either. For example, here's the beginning of the square root of 2, but it continues on. That's not all of the square root of 2. It keeps on going, and there's no repeating block of numbers. Now, if it did end a repeat, if a decimal does end a repeat, it would be a rational number. And so there is a nice little proof to show that the square root of 2 cannot be written as a fraction. That's how we know that it is irrational. Now be clear that even though it cannot be written as a terminating repeating decimal, it does correspond to a point on the number line. So it corresponds to an exact length. In this case, that red line is giving me the distance from 0 to the square root of 2. And if I copy over that red line, this line, the length of this red line is exactly the square root of 2 units. Now I'm going by the basis that from 0 to 1 is 1 unit. So from 0 to the square root of 2 is the square root of 2 units. Let's look at the relationship of these different types of real numbers. Remember the natural numbers, 1, 2, 3, 4, just the way a child would start counting. They're inside the whole numbers because the whole numbers include all those natural numbers and also 0. All those natural numbers and whole numbers, they're all inside the integers. Remember, the integers are the whole numbers plus their opposites. And then the rational numbers include the integers. So you see we have these nested sets. The natural numbers are part of the whole numbers, which are part of the integers, which are part of the rationals. Now we have to jump to the side and see the irrationals. There's no number which is both rational and irrational. They're entirely disjoint sets. And when we put them all together, those are the real numbers. That's a nice little diagram to help you with the structure of the real numbers. We'll move on just to talk about notation. The natural numbers, we use N to stand for the natural numbers. We use a W to stand for the whole numbers. Using some German word, we have Z to stand for the integers. This is sort of a stylized Z. You may see it written like this with a kind of a double bar, or I think you may even see it this way, sort of a different kind of a Z. Check to see how your teacher wants you to write it. Maybe this is another way that I've seen it. Some teachers will just write it as a Z. So just check that with your class to see how they're writing it. Now the rational numbers, we use a Q, and that's sort of a fancy Q, but a regular Q is fine for the rational numbers. The irrational numbers, oddly enough, we have no symbol for that. And there's a few times I've seen people make up some symbols, and that's okay, but there's no really commonly known symbol for the irrational numbers. And here's our real numbers. Now that's kind of a fancy R, but I would normally write it this way. This is how I would write the symbol for the real numbers. Here's a little more additional notation I want to mention, which is you could talk about Z plus. These are the positive integers. And if that kind of looks like the natural numbers, if you're thinking that, you are correct. We could write Z non-neg, meaning the non-negative integers. And if you're thinking that kind of looks like the whole numbers, you would be correct. And we might also use R plus or R non-neg. We might also use something like R minus to mean all of the negative real numbers. And that is the end of our video.